Imagine a universe where every particle you know, every atom in your body, every speck of dust, every distant star, has a mysterious twin. A mirror version that looks identical, behaves almost the same, yet carries an opposite charge. Now imagine that this idea, something that feels like pure science fiction, was quietly born not from an experiment, but from an equation. And at the center of it all was one man, Albert Einstein. In the early 20th century, physics was going through a revolution. The old rules of Newton were being challenged, and a new understanding of reality was emerging, one that was stranger, deeper, and far more powerful than anyone had imagined. Einstein, already famous for reshaping our understanding of space and time, introduced the world to his theory of relativity. But hidden within his work was something even more profound, a relationship between energy and mass so simple, yet so explosive in its implications, that it would change science forever. When Einstein wrote down his famous equation, E equals mc2, he wasn't trying to discover antimatter. He was exploring how energy and mass are connected, how matter itself is just a condensed form of energy. But what he revealed, perhaps without fully realizing it at the time, was a doorway, a mathematical truth that suggested something radical. If energy can become matter, then under the right conditions, it could also create a mirror version of matter. Something equal but opposite. At first, this idea didn't immediately lead to the concept of antimatter as we know it today. Science doesn't work in sudden leaps. It moves in steps, often guided by clues left behind by great thinkers. Einstein's work laid the foundation. It gave future physicists the language and tools they needed to go further. And soon, those scientists began to ask deeper questions. If nature is symmetrical, if equations allow for multiple solutions, could there be another kind of matter, hidden, invisible, yet perfectly real? Years later, building on the groundwork Einstein helped establish, physicists began uncovering evidence that the universe might indeed have a kind of shadow matter. When equations describing particles were solved, they didn't just predict known particles, they also predicted counterparts. These counterparts had the same mass but opposite properties, like electric charge. It was a shocking realization. Nature, it seemed, was more balanced, and more mysterious, than anyone had imagined. This is where the story becomes truly fascinating. The discovery of antimatter wasn't a single moment of triumph, but rather a chain reaction of ideas. Einstein's equations didn't scream antimatter directly. Instead, they whispered possibilities. They suggested that the universe operates on deeper symmetries, and that for every piece of matter, there might exist an equal and opposite partner. It took years of exploration, debate, and experimentation before scientists could confirm this strange prediction. And then, finally, it happened. Antimatter was observed, real, measurable, undeniable. Particles that behaved exactly as predicted, identical to matter, but with reverse charge. When matter and antimatter meet, they don't just collide, they annihilate, releasing enormous amounts of energy. In that moment, Einstein's equation comes alive in the most dramatic way possible. Mass pair ya vel air ashcha. Ya te esya into pure energy, exactly as E equals mc2 describes. What makes this story so powerful is the idea that something so groundbreaking wasn't discovered intentionally. Einstein wasn't searching for antimatter. He wasn't trying to uncover a mirror universe. He was simply following the logic of mathematics, trusting that the equations would reveal truth. And in doing so, he unknowingly set the stage for one of the most astonishing discoveries in modern science. It reminds us that science is not just about answers. It's about curiosity. It's about asking questions that no one has asked before, and sometimes finding answers to questions you didn't even know existed. Einstein's work is a perfect example of this. His theories didn't just solve problems, they opened doors. They revealed a universe far more complex and beautiful than anyone had imagined. Today, antimatter is no longer just a theoretical idea. It's studied in laboratories, used in medical imaging, and explored in some of the most advanced experiments on Earth. Scientists are still trying to understand why our universe seems to be made mostly of matter, even though the laws of physics suggest there should be equal amounts of antimatter. This mystery remains one of the biggest unanswered questions in science, and it all traces back, in part, to Einstein, to a man who dared to think differently, to question the nature of reality itself, to follow equations wherever they might lead, even if the destination was unknown. His accidental role in predicting antimatter shows us something profound, that sometimes the greatest discoveries are not the ones we aim for, but the ones we uncover along the way. So the next time you hear about antimatter, something that sounds like it belongs in science fiction, remember this story. Remember that it began not with an experiment, not with a machine, but with an idea, a simple equation, a moment of insight, and a scientist who changed the way we see the universe forever. Because in the end, Einstein didn't just reshape physics. He revealed a hidden symmetry in reality itself, a balance between matter and antimatter, between what we see and what we're only beginning to understand. And perhaps most importantly, he showed us that even the most accidental discoveries can have the most extraordinary impact. That is the power of curiosity, that is the beauty of science, and that is the legacy of Albert Einstein.